Thank you. Um, Good morning or good evening, everyone. I'm really glad to be able to present for the first time at ISEC. Today I will talk about the part of my PhD on population dynamics of migratory caribou. We have deliberately focused the introduction on caribou ecology, as I really want you to understand the application of the model and why I built it the way I did. As I mostly teach myself into Bayesian analysis and IPM, I would really enjoy your feedback and advice. So this circumpolar map shows you in red that most caribou and reindeer populations are in decline in the north, including the Rivière-au-Feuille herd and the Rivière-Georges herd in the north of Quebec and Labrador. And as you can see on this graph, they have faced sharp decline. And in only 2 decades, they respectively lost 75 and 99% of their population size. And in 2017, the Committee on the Status of Endangered Wildlife in Canada assessed this population as endangered. The situation is even more critical that several indigenous communities rely on caribou for food, but also culturally and economically. And the caribou is also a key species of the Nordic ecosystem. So we need to fill our understanding of these declines to improve the management and the conservation of these populations. Aerial surveys were done by wildlife biologists, but they are costly and difficult to do for migratory species that are largely distributed in a remote area. And as you may have noticed that some of our aerial survey data have huge confidence interval. Hopefully, we get more data on demographic traits to compensate for our lack of survey data. We can count on long-term telemetry data over the past 30 years with more than 400 adults collared from both herds. And we also have recruitment rate at 6 months old, represented by the number of calves per 100 females counted on the field in the fall. And in the past 3 years, we have pre-weaning survival thanks to camera collars. Previous studies also brought winter pregnancy rate and also number of harvested individuals, and also the proportion of the different segments of the populations. But as nothing's perfect, you can see that some of these parameters have sparse and punctual data. The table at the top shows you the available data for the Rivière-au-Feuille herd, and the one below are the data for the Rivière-Georges herd. Many of these estimates are good, especially in the recent years, but some of them are poor estimates and others have unknown precision. And we have several missing data. But let me show you what some of this data look like. For example, this graph represents the fluctuation of female annual survival for the Rivière-au-Feuille herd since 1994, and some confidence intervals are quite large in the previous years when we had only 20 females marked per year. Then it started to improve in the recent years with about 100 individuals monitored. And this is the recruitment rate for both herds. We can see large fluctuations of recruitments that we know are mostly linked to large fluctuations of calf survival. So what I showed you until then were data per year, but the migratory caribou's life is shaped by the seasons. And on this map, you can see the geographic range of the Rivière-au-Feuille herd, over 630,000 square kilometers in the north of Quebec. And previous studies identified 5 biological seasons. We have calving and summer range use in the north and winter range use in the south, and 2 migration in fall and spring of about 800 kilometers each. We found that factors influencing demographic parameters may change between seasons. So we were wondering which of these factors may impact population size. So tourism or objectives. We want to improve the conservation of this population by enriching our knowledge on the demographic changes. And to do so, we wanted to gather all the data available to reconstruct the population size and its fluctuation and see how they fit together. Which led us to our objectives for the model. We wanted to build a model which could reflect caribou ecology, but also take into account the seasonal variability and use these seasonal components to decompose internal variations. And finally, we wanted to include environmental effects on seasonal demographic parameters, so we would be able to predict population counts for the next 5 years. And that's why we used IPM models. So this slide will be the last one on pure ecology. It explains how we built the model, and this graph will help you, I hope, to understand how seasonal components are intertwined to lead to annual modeling. So this is the life cycle of the migratory caribou and both populations following the same patterns. So you have calves, yearlings, and adults, and a seasonal time steps. Aerial survey were done in summer, so we aligned our model to estimate population counts in summer too. And we have seasonal survival giving us annual survival for both yearlings and adults. And we have calf survival at calving and at 6 months, thanks to recruitment and the fecundity rate. We have also fall classification, which gave us the proportion of different segments of the population in fall. And we considered that this proportion was the same in summer. And finally, we have the number of harvested individuals in fall and winter. So now let's go to our model. This is a cycle diagram of our model, including a capture-recapture model for adult females. For calves and yearlings, we use informative priors based on previous knowledge, and we use available sets of data for other parameters. We ask the model for derived parameters such as growth rate and use IPM as retrospective evaluation of input variables, so we could compare confidence intervals. So the CR model is a multi-state model with seasonal steps, and migration of individuals was allowed until 2012 when the two herds definitely split. We accounted for colors malfunctions and missing mortality signal using a live encountered and dead recovery model. That's why we have parameters such as probability of recapture, dead recovery, fidelity to site, and migration. Priors for productivity were based on official reports, and as they had no precision, we built a normal distribution centered on the known estimates and added an error around it. And the error was chosen considering the process to obtain the data. We did quite the same for sex ratio. Since yearling sex ratio was unknown, we sought advice on the literature and found acceptable to write a normal distribution centered on 0.5 with an error. And for adult males per 100 adult females, we had already like adult female sex ratio available data. The third important part in this model of the population is the population dynamics and count. And I want to take a moment to explain the probability factor in the binomial distribution. I detailed it for for juveniles, and the probability that a juvenile would be counted in the population is the product of the probability for the female to be pregnant and then for the female to survive since the last count. So it means she needs to survive summer, fall migration, winter, spring migration, and the calves need to survive calving season to be counted in the population. So this will be the same for juvenile becoming yearlings and yearling becoming adults. For adult females, so adult female count is a sum of yearling becoming adults and females that survive the previous years. And as you see, we had this information because just for now, we are using the number of females harvested to set it as the lower values that the model could give to adult females counts. But we really want to improve that and include it directly as a parameter in the dynamic modeling. Then we have the population count in the model which are the sum of the number of juveniles yielding adult females and adult males. We are estimating using the adult females count with multiplied by the ratio adult male female. And finally, we linked the model population counts to the aerial survey using a normal distribution centered on the model counts. And these are the results for 2001-2018. I want to mention that these are just projection models for now. We gave the model an image value corresponding to the first aerial survey in 2001. Then we let the model use the parameters given to calculate the population count. So we can see that demographic parameters are quite consistent with the aerial survey for the Riviera George, but less for the Riviera Feuille herd, and which may be partly explained by large confidence interval on survival for the first years for the Riviera Feuille herd, when we already had good estimates for the Riviera George. And right now we are working on models using the 2016 aerial survey as in its value, and so we want to make the model to estimate the population counts, but going back in time. So what we come next, we will explicitly include harvesting in the dynamic modeling, and we will try to predict population size based on climate and resource prospect, and then build a 30-year model. So the government would also like to have formatted models that could be easily used by wildlife biology. So I really want to thank you for your attending, and thanks my founders and my supervisor in Quebec and Aberdeen.